yourself first, and then because you actually started on NXT before I did, so.
Sure. Okay. My name is Michael Aldridge. Been working on sort of computer graphics, programming and stuff, and having fun with animation and all of that for probably 4 or 5 years now. Just sort of recently getting to have some fun on NXT, which is a tool that we started building a couple of years ago, myself and a couple of other people who've spent quite a bit longer than myself in the industry. And we spent some time working on NXT, and then NXT went through like a handoff to someone else, and then it circled back around. And now I've gotten a chance to go back and work on NXT recently with Sunrise. That's where Lucas and I have spent the last year working on NXT. And before I get to just what NXT is, I'll let Lucas introduce himself, and then we can start to talk about what NXT is and where it's gone.
So I'm Lucas Brown, and I've been working on NXT for the last 18 months or so, and kind of we brought it into being a tool that we could actually use. When I kind of started, it was a very prototype thing, and now it's something that we're actually capable of like building production rigs on. And before this, I worked as a rigger for a mobile game studio, and I was using mGear to do rig builds there. And I wrote my own face rig that I kind of tacked on with post steps, but I kind of always wanted some better way of having scripting that was better than a giant wall of code that I highlighted and like hit Control Enter on in Maya, or like a shelf button. You know, I wanted some way of organizing my scripts, but I never really had it. But I was talking to Michael. We went to the same university. We worked together on game jams and stuff, and he had started working on NXT, and I kind of didn't understand the power at first, but later on it became very apparent that this was a very powerful tool that we were working on. And I'll let Michael explain how it like actually started, because I wasn't there for the real start.
Yeah, so I mean, to give credit where credit is due, Aaron Adams, who's not here with us, but Aaron Adams is sort of the big mind behind NXT, who brought it to me and said, hey, let's start building this thing. And NXT is kind of a way to layer workflows and processes, and specifically when it comes to Python code. So our big sort of first use case was rig building. So you're going to build a base biped rig with good weights and good fit and fitment overall, right? It's the rig moves how you want it to move and that kind of thing. And you're going to come along to the next human character who looks in most ways just like the one you had before it, and you kind of want exactly the rig you built before, but with all these little tweaks, right? It's like, oh well, the shoulders are a little higher on this character, a little broader on this character, any sort of little fitment stuff that comes along with it. And so NXT is built for you to sort of look at that rig build as one piece that is layered upon and customized by each new character with respect to rigging. So rigging was kind of our big early focus when it came to, hey, you can lay out these sequence of events that happen inside of a rig build. Joints, deformers, cleaning all of that up to get prepared to actually send off to animators. There's all these kind of big steps. And when it comes to building another character, most of the time those steps are exactly the same. And you've got all these little bitty pieces. You're like, oh, tweak that. Oh, the name of the character is obviously different. This character's legs are a little bit longer than the last character's legs. So that's kind of taking those tiny customizations and distilling those details down into a layered approach to rig builds was sort of the big win we built for ourselves and the problem we understood that we tried to solve. And once we started building rigs with NXT, we started actually feeling how that felt and how the sort of workflows worked with layering, and how nice it was to be able to say, oh, well, that's kind of not my problem, for lack of a better term. The previous layer already solved all these problems for me. I just get to make my rigs fixes. And we've started to work over the last year, especially around taking that thing that we built specifically for rigging, and specifically for rigging in Maya even further specifically, and build it out into a pipeline tool that works not only in Maya, but in our other DCCs that support Python, Blender, Houdini, everything else. And building NXT as a way to layer not only rigging workflows, but workflows across the pipeline when it comes to creating assets, getting assets moved between people. And, so much of our work has to do with moving things from one person to the next in a clean way, or moving the things from one person to the next in the format that the last person wanted it in and the next person wanted it in, and those sorts of things. And once again, often those processes are kind of the same, but they have all these little bitty specialty things where it's like, oh, this department really wants this special thing. So we're going to make sure we get that customized and tailored just for them on top of the base process that's been laid out. So before I get even farther, let's go ahead and get into a rig, Lucas. You've got the openRig, I think, up, right?
Yeah. So I have this this model and this rig. So this is from openRig, which is something you could download and play with today that's using NXT. And we've been so nice to be gifted the rig from Squarebit Studios and the model from Sergey. And those links are somewhere around this video, I'm sure. But this on the left side is NXT, the actual software. And then obviously on the right here, I have Maya open, and the rig is built. It takes a fair bit of time to build because this is Disney level rigs. Like, this is very heavy. There's a crazy face system on here. IK-FK matching built into the rig. It's very, very complicated. But the basic workflow, the basic flow of the rig is just laid out here in these nodes. This big green button kind of just indicates that this is the start point for this graph. And these heavy lines that go across kind of just show how things are sequenced together. And all the different colors that you're seeing here are related to these layers that we have up on the left here in the layer manager. So each layer is very simply, it's just a JSON file. We have a bunch of JSON files that layer together, and everything kind of matches based on node path. So if you're familiar with like how Houdini handles node paths or how Maya handles long paths, in Maya you have like the pipe separator between each path, and in Houdini you have kind of the / like a file system. When we first started, we were using dot separators for everything, but that didn't make sense because we couldn't determine the difference between what was a node and what was an attribute. So our node separators are slashes. So you could kind of think of like nodes like a file structure, and our attributes are just attributes on Python objects. And so they inherit in these little hierarchies. And when the hierarchies execute, they execute depth first. So in this case here, like we would run load model, load file before we would do load joints. So you can kind of build a picture of how that's going to execute. And then on the left, we have this huge build view of every single node in sequential order that it's going to execute. So this is, I think, about 1,300 nodes in here, give or take. These are folded up, like we have nice convenience to fold them up. But it's very easy to follow. So if you're a new rigger and you don't really understand what rigs are, or you're not you're not used to working in this data-driven rigging system, it's easy to pick it up and follow. We've had, I say we, the rigging team has brought on new riggers, and they've been able to pick it up within a matter of an afternoon. They can understand what's going on, they can see it, and they can start working on their characters. So all of our this character here is derived from the openRig base biped. So all biped characters are pretty much the same thing. They'll have different, unique skin weights, and they'll have different joint positions. But all of that's kind of set up by a curve system, which we're not going to really get into how openRig works. We're here for NXT really, but once you've done that basic setup, you're able to layer on. So this roller girl, let me save the layer so we can read the thing here. She normally has roller skates on, but we took those off for this. She's just a very slim override to the to that base biped rig. So a few nodes are this lighter green color, and those are ones that have a few, maybe 1 or 2 attributes that change. Like her name is different, and maybe some multiplier is different about like the size of her controls. So we can load all of these attributes into nodes, and we have this little property manager that lets you see every attribute that node has access to. And we have kind of a varying level of inheritance, which I think Michael should probably talk about all the different inheritance arcs that we have, because there's several that we've kind of boiled the whole thing down to.
So we've been through a lot. I'm going to try to take it from as big of an angle as I can, because I don't want to there's so many things to get into. Sorry about that. So we can see that there's all these layers on the left that Lucas has got loaded of the different colors and the pieces of the rig build. And on each of those layers, there's going to be some number of nodes defined. And Lucas talked before about our node paths being slash separated. So I mean, when I talk about node paths, I tend to talk about them as addresses. So they're just an address that some information is at. Now, when you layer all those things on top, the same way that in Photoshop or Nuke, the pixels that are in the same pixel position overlap each other and replace each other, you get the same effect when we load layers of our nodes on top of each other. So if an upper layer defines some attribute of a node, the attribute from that upper layer is going to lay on top of the attribute from the lower layer and replace it. But it is going to replace only that attribute of the node, not the entire node itself. So the node's code will still be intact. And since we're talking about attributes and code, we can start to get into attribute substitution just a little tiny bit. We don't want to go too far down that. But I'll talk a little bit more about layering. So we've got this layering that happens sort of at the file level, where all these different node addresses are then laid on top of each other. Once that happens, our nodes, because they also have addresses, they're in these hierarchies and stacks vertically. And we get a different type of inheritance inside of a stack. So if a root node, a node at the very top, who has a path of just slash and then their name, that node is going to define attributes of its own. And in this case, on the left node that Lucas has got selected, it's going to define some things about what side it is. Like in this case, obviously the side is L for left. And now that side attribute is going to flow downward into all of the children and grandchildren and great-grandchildren and all the descendants of that node. So everybody running underneath that node kind of gets that context of what side is in this current context. So we've talked about how we can bring attributes in a layering context, or we're just going to lay information on top of each other. And we talked about how attributes can flow downward through nodes. So there's one more way, and that's instancing. So I did talk about the left stack here. Lucas, do you want to talk about the right stack and how that relates, how instancing relates to those other two ways of inheriting?
So this is the last crazy thing that we're going to throw at you. I know that this is like a lot of information really fast, but it's important that we get these terms out so that we can use them, because it's kind of the axioms that we're built on. So we have local attributes which live on the node. We have attributes from your parent, and then we have attributes from instances. So instances are not to be confused with object instances in Python. They're more like an instance of a piece of geometry in Maya. So you could instance in a chain many things, and they inherit, the position of it. So if you imagine you had several cubes instance of each other and you moved one vertex, you would see that kind of ripple down that whole instance chain. So we have the same thing going here. On the right hand side, we're instancing the left side of the whole character. And the only thing that we're changing about that is these 4 attributes at the top. We're getting all of that code, all of the setup for free from the left side on the right side. And then because of this parent inheritance, on the parent right node, we just say, oh, now the side is R and the side multiplier is -1. That's it. And then everything else happens for free. And any changes you make on the left just fall over to the right, and everything kind of just keeps working that way. So there's no duplication of code. It's a live visual look into it. So like deeper nodes, you can visualize like, oh, this control is going to come out called arm right. And if you click on the left, oh, you can see that the string is going to be arm left. So it's a very visual way of seeing that inheritance, instead of, normally you might just write a script and be like, okay, well now let's make this left, and we'll make a class called left, and I hope it works. We have all these variable names, but we can't see what's really going to happen. Maybe if you had a debugger, you could, sure, but
Lucas, let's
very
talk
low
about
rent.
Attribute inherit. Let's talk about attribute substitution as we go on to a simpler demo where we don't have so many pieces of wire to look at.
Yeah, let me open the little ball rig demo here.
If we can clarify anything, if you feel like we should go back and go over something again.
No. It's good for me. I know I will ask later some questions, pretty dumb probably, but yeah, I think I don't want to cut your flow. I think it's great.
Okay, we'll try to keep taking the right size steps here. So we kind of talked about where attributes can come from and how they live in an address, and that address can be overridden in a couple of different ways. But the reason that we like using attributes and how they relate to the code that's being run inside of a node is attributes are sort of a way for us to do text composition in a little bit of a way where it's like, we're going to refer to our attributes inside of our code, and we're going to put in a value inside of our properties, inside of our attribute editor. And then when we have a system called resolve, which is not super complex, it's some pretty basic string substitution, but it's really nice to be able to sort of project forward into when my code runs, what is the name of the control that it's going to make be named. And that's specifically with regard to the sort of left and right. It's a really nice to sort of get that forward look. So you can, Lucas, I'll hand over to you so you can talk about both the syntax and kind of start to draw some nice direct examples in this graph.
Yeah. So we have these things that we call tokens, and it's our way of accessing attributes. And again, it is just string substitution. It's not rocket science. It's just, it gives you this syntax, which is the $ squiggly bracket. And that refers to an attribute name. It can refer, you can refer to other nodes, again, using that full path paradigm that we just talked about. But if you don't give it a path, then we just assume that it's local. So this attribute control name is local. And then you can see I'm in a mode here that just doesn't resolve anything. It just shows you what we save in the save file. So this is kind of like a compound thing. So we can nest these as many levels deep as we want. They recursively resolve. So this control name down here will resolve into, well, control name, because I'm not actually in anything interesting. Let me go to something interesting. Should probably build.
So just to be clear, Lucas is going to take us to the same node, actually instanced off into an actual rig build. Before we were sitting over here at an island, which is where we sometimes build kind of like these prototypes of something that we're going to take off and use somewhere else.
Yes. So, right. So that was my prototype for how I make controls in all of this little rig that we're about to build. So this is several instances deep. Like I've assembled a leg, and now I've put it on the left side of the character, and this is going to make, I think, the hip control. So it's going to be called, the name that's going to get spit out by our resolve token system is going to be leg upper left, and that's just because we're in that left hierarchy. We're under the leg, and then we just are down here in wherever I was, the upper make control. So yeah, that control name that we saw, which might not actually be local because it's being resolved, sorted by name. This is me live demoing, finding a name.
Yeah, finding things in a list is never easy on a demo, so good luck.
So this attribute control name, we don't even override it as the rigger here. It's been set up in a way that it will automatically resolve correctly. So you can see that it's not localized. It's coming from that node way over on the other side of the graph. It's coming from the control make control node. So in that token, we have the name underscore the side, and then our control suffix, which in this case is right above here. It's just underscore CTL. So all of those things resolve together to spit out our name, leg upper control, and you get that instant feedback of being able to just flip between these two modes, and you see everything is updating based on that. So that it gives people who don't have a lot of programming background a really cool like spyglass into what's going on in the code. And the people we've introduced this to who are less advanced in programming find this like they learn how Python works in this way, because you're able to visualize it in a way that's simple and intuitive, as opposed to like pulling out your whole debugger and attaching to Maya and like stepping through everything and trying to figure it out. This just lets you see what's going to happen when this actually runs. The other thing that maybe Michael should talk about, because I've been rambling here, is the different data types and how those might resolve differently as far as quote lines go or quote marks go.
Yeah. So this is something that once we sort of saw resolve happen, it was clear, the value was clear to us, like sort of that you can project forward in time and sort of understand some things. But it comes with caveats like every other good thing, right? And resolve really works the best on built-in Python objects, integers, strings, floats, booleans, and then basic list of those things, right? List of numbers, list of strings, and those sorts of things. And that specifically has to do with the fact that we're just string substituting them in, right? Sort of no sort of big special machinery. And what that comes down to when it comes to quotes and strings, which is sort of a little bit different. So with a number in Python, 1, right? It's just the character 1. And when you use it kind of anywhere, the character 1 means 1. And with a string, you know, the string sort of is the characters that make up the string. But when you use it in Python, you need to have quotes around it. So the way we've chosen to handle that right now is that whatever is inside of the attribute value at the top, instead of our attribute editor and a property editor, where whatever is there is what will be represented in your code block. So if you have plain text with no quotes on it up there, it's going to come into your code block substituted with no quotes at the bottom. And if there are quotes up top, it's going to come down with quotes in the bottom. And because of our substitution syntax sort of just fits alongside Python, and all of our resolve happens before Python is running. Like, we're not changing how Python runs here. We're going to resolve some code and then hand it off to Python to run. We know you can sort of really quickly tell if you're going to get a syntax error because something's not wrapped in quotes, or if you're, you know, because that is going to resolve right in front of you into regular Python. And this is something that is not perfect and is always going to have caveats. We really think that for the ways we're using it in terms of being able to just define that one character L or R and then see that sort of flow forward into everything, we think that the big win is worth those caveats. And we're really having a lot of fun seeing how the resolve happens. And as we've used it in a pipeline context, that's when I've actually felt the best about it, because I've been able to do sort of that string concatenation that happens when you need to find an asset, right? It's like, it's in this directory and it's this type of asset and all these other things. You get to see that resolve happen quickly. You don't have to like go run the code, watch for the output and go, oh, that's where the problem is. You can sort of see all that concatenation, go, oh, got a little bit wrong, fix it. You have this really tight loop on being able to fix those types of problems, which feels really good.
And I see like you have also the type that it's automatically set when you set the value on the attribute. So the people can also check easily there if forgot the quotes or something on the string, you're gonna say row instead of string, I guess, not like there. Yeah, exactly. So now it's a string. So it's also very nice feature, because it's easy sometimes to forget stuff like this. Very simple.
Right. Well, and I think the reason we like Rob, because it is like, it's just as good to use as a string, but it's not a string yet, and you should know that, and you should use it in the right way.
Yeah. And if you have any familiarity with PHP, it's kind of an idea that PHP lets you do, where you can just sub in like a bunch of code into a spot, and we let you do that. We have other types of tokens than just this one. Like, we have ones that validate file paths. We have ones that read files and put the whole file content in there. It gets very complicated because we've found very like complicated use cases where you want to have this kind of access to it. And what Michael was just talking about with the guessing the file path, I have this example here for the, let's see, the load model. This file path would be really crazy, like, because it's a relative path. It's like saying go up 3 directories and then put in the variant name, and that would be really ugly and hard to understand if you're writing that in Python. But here we kind of get that instant feedback of like, well, what would that path be if I do this? And you're able to flip between them and see like, oh, cool, that is a valid file. Like, that is the one that I expected it to be. So like, it would teach you, obviously you'll learn about relative pathing. You'll learn about, oh, this is how the file path system actually works in a computer. But it also just gives you that quick check of like, oh yeah, because you know, so many times I go over and I open up another Python terminal, I'll import OS and be like, does this path really exist? Did I make this correctly? And this gives you so many like little easy ways of solving those kind of frustrating problems that you shouldn't have to be wasting your time on.
Lucas, do you have this ball rig built, or are we going to build it live here?
We can build it live. We'll see what happens if we do a live demo. I have too many NXTs open. Let me make sure I don't have. Okay, so this will, I'll speak through it really quickly. It's just going to load, It's going to make a new scene. It's going to load a model of a ball with some legs. It's going to build a basic rig hierarchy, and then make like the most simple IK leg system, and then just parent constraint the joints and the mesh together. It doesn't do anything fancy, but I think this covers enough of what NXT is capable of. I didn't click on the output log. So we have this really nice output log that gives you links to the currently running node, so you can quickly click through if something goes wrong. So yeah, this just gets a little ball guy here. I have this thing that will apply animation to him. Oh, maybe not, because I moved it.
The way
live demos. Yeah, so we have a really good system. It's not without its faults, but it does its best to catch errors in your code and try and tell you what happened. So it tells you the file path of your open graph, and then it says line 3 in apply anim, which is this node. So if you saw it here, I'll scroll away. I'll click this link. It focuses, and it also selects that node. So if I deselect it, it's very valuable. And these are things that we didn't think of when we first wrote it. This is stuff that's happened through iteration of working on a production and people asking questions. So yeah, apparently this file that I have is not here.
If it's not a big deal.
Oh, I know why it's not here. It's because I have the environment loaded to build that's really deep. I have a different environment in my Maya right now.
So the rig works, right? We can wiggle him with his hips around at least.
Yeah, he do be moving. But so yeah, this is a very like dumbed down example of what we're kind of doing in openRig, like the system they've built there. As far as building a limb, well, I don't build a limb here. I just build a leg. I don't get too deep. But we build a prototype leg or an archetype leg over here. And that's saved on the rig layer. So if we just look at the rig layer, oops, that will turn off all of the other stuff for the actual ball rig. So the only thing that builds here is this one leg. And then we just instance it over, like I said, to be the other side. So we don't have to like duplicate our code or anything, which cleans up your wall of script. And then we have a very simple thing that will make these controls and apply a size and a color to them, as well as their zero group, and then somewhere to snap it. A very simple thing for making joints and then keeping track of them. So this is a good segue into the stage object. Michael, if you want to talk about it, because you've been talking about the stage object recently.
Yeah, so I kind of talked about tokens before, and sort of their big use being for this text compositing, right? We have this resolve system that you can flick all the attributes between, where it was sort of text compositing all these different attributes together. So attributes of these objects can be changed during the code. You can modify the attributes that are visible up there and that inheritance still happens. Your children will still hear about those attribute changes. But because of this text substitution system we're building, this is not the place that is best for your Python objects. So you're going to build, all kinds of these. People build custom rigs. They have custom Python objects that represent their build in progress or their build in memory, whether it's your FKIK system or some other part of your system that's relatively complex and hard to model. And once again, going back to what Lucas, we build it, right? People are like, man, where do I put this stuff? Because I can't put it through an attribute. And it's like, so we built this thing that we're calling the stage. And the stage is sort of the central through line of your build. When your build starts, you're given an empty stage, and then you're going to put anything you want onto it, Python attributes. So stage dot anything you want, put anything you want inside of it, and that is going to carry on through your build into every node. So every node has access to this object during that build. And that stage object actually, to sort of preview on to the next thing, which we probably should talk about, is actually your world node. And so the world node is kind of the parent of the entire graph. And we have a way to access that. And we'll talk about that a little bit as it relates to imports, I think. But keep going with the stage object and how we use it, Lucas.
Yeah, so the stage object is a great way of passing around kind of like global data for your build. You could use the globals keyword. We don't stop you from doing that. This is just a handier way of grabbing it off of there. So what I'm using it here is just to track the last joint I made. Again, this is like a super simple hack together example for this. But we're just tracking that last joint that you made, and then to build that FK chain, I just parent to the last joint I made, and then I reset it. And I have this little thing of, I can turn on the token here, of like, I have a couple keywords and attach, like if it's the root, then go grab the root joint and attach to that. And if it's the last joint, grab that. Or if it's something else, you could give it a name of an object. It's just to kind of demonstrate different ways that you can use your tokens to do sort of flow control of what's going on. You can control switch states like that. But the stage object is actually this. So if you double click on these layers, it takes you to what we call the layer node or the world node, or the stage object. And in there, you're able to do your imports to like start up your thing. So if you pick up NXT today and the first thing you try to do is like use CMDS, you're going to find that you import it in one node and the next node it says CMDS names not defined. And that's because we do some not so clever cleanup of the globals dictionary between each node to make sure that each node is encapsulated in its own scope correctly. It's really complicated why it has to be that way. We've tried a lot of ways to get around it, but the best thing we've come up with is putting all of your imports on that world node, and it gives you a clean spot that all your imports are over there. If you have a problem with an import, go over there. You can do arbitrary code in there as well, and it does run in a slightly different scope. I don't think we've seen many people apply that. You can usually take care of your work that needs to be done in a node, but this is where you would go and put all of your imports for your thing, and that is on that stage object. We also have these attributes that are on the stage object because it works just like a node. And every root node is secretly parented to that layer node. So they inherit all these attributes. So any node in my graph over here, if I click to it, will have all of those attributes that existed on the world node, and they just have this source path here where we track where did this attribute really come from. They're all that / character saying that came from your overlord world parent.
And that / is another link, by the way.
Yeah, these are links. If you click them, it will select that node. So if you go and see like this from the left leg, it will select the left leg. We also have, this is getting off the rails a little bit, but if you right click on it, it can tell you all of the previous opinions of that attribute. So this says that the left node dot side said that the side was L, not R. And the side mult was 1 if I right click on that one as well. That might be really small on the screen, but we try to expose this data as much as possible and expose what we're doing and not make it a black box. We want it to be very clear, like this is how your data got here. When you're debugging it, you can quickly click through. We have these little locate buttons that will let you jump to, I'm an instance of this node, but where does this node actually live? You click the button and it takes you directly to that node.
If you've run the build, can we look at the cached view?
Yeah, if I haven't broken it somehow. Let's go look at, why does it think these are all devalidated? Let's run it again and see if it cleans itself up here. There we go. So this is cache view, doesn't look like anything much. That's because I'm not really doing anything different than what you saw in resolved, but what cache view does is it shows you what actually ran. So Michael, explain to us when we resolve so that I don't keep rambling here.
No, it's okay. So resolve happens for each node immediately before the node runs. So this is specifically with regard to inheritance. We've talked before about how, the attributes that are on your parent, if they're changed, you're going to receive that changed information. So in order to achieve that, we're going to resolve right before the code is executed. So we can show you a pre-resolve inside the editor that is 99% of the time correct. except in the cases in which your parent's code changes those attributes. So that's why we're resolving right before we execute. And in those cases, when something was different from the resolved view when you watched it before it executed, and actually the code that ran, that's when the cached is the biggest value, is because it's going to give you a way to see what happened the last time this code ran, what was the output information. And even if not using that information for inheritance, we also have seen this being really useful for just the debugging sake, what happened last time. So, you can keep track of a list of all the all the joints that were created in the entire rig build. This is a bit of a contrived example, but it is the kind of information that you might write down during a build. Look, we got Lucas to give us an uncaught exception while we were demoing. We really did it this time. So anyway, going back to the cache view, it's there for what happened last time. And we can keep track of any information during our build, and the cache view is going to give us our information of what happened during the last build of this graph. Do you need to restart, Lucas?
No, it was fine. It was just complaining about the world node is apparently the wrong instance of an object. I wanted to demonstrate what you're saying where it actually changed, because we do pick up those changes when they run. I was gonna just try and live demo that. And
I think after this we have one more, sort of prepared demo. Is that right, Lucas?
which? Oh, we're gonna go full guns and show it working in Maya and Nuke at the same time?
No full guns. No, but I was going to say the quad ball. If we wanted to just show the quad ball for just a minute, and then we can show the fun, exciting demo too. I'm just less positive it's going to work. I was only going to speak to, hey, we've got one more demo we feel pretty good about showing, and then we'll try to give you an extra flavor after that.
Right. Yeah, I can build the quad one just to show off again how powerful this layering system really is. So this we didn't say this, did we? We didn't say that all the attributes are accessible via the self key name, so which is a very
we may have alluded to it, but we didn't show that off. So why don't you talk about it?
So I just created this attribute and set its value to 1, 2, 3, and then in the code block we're going to set it to 4, 5, 6. If this works, and we go and look in cached view, yeah, there we go. This is really small, but in cached view you can see that the value is flipping and you're able to see what happened there. That of course works with resolve. So if you do something crazy complicated in one node, you'll see that change picked up in the cached view. Super valuable for debugging. But yeah, let's try and build the ball rig with 4 legs, which is the ball rig plus a layer on top that basically all I did was take the leg and then instance it down and make a leg rear. And then I messed around with how I attached the mesh. I just made another copy of the mesh attach node. So there's nothing really crazy new going on. It's just those few nodes that got localized. And
once we've run the build, let's show off solo and we can talk about what's on that layer.
Yeah, let's see if it actually builds. It's longer, obviously, because we're building, twice as much stuff. I should have cleared the log first. There we go. Right. So this is our little guy with 4 legs instead of 2. Wow. Amazing. Keys. Where's what node do I have here? I wanted to show, I have it sorted the wrong way. Here we go. So yeah, this is all that we actually did for this is the only differences between the biped version and the quadruped version. Now, realistically, you're not gonna build a quad out of a biped. In the legs are different. Yeah, we get that. But this is just a quick demo to show you of how you could derive crazy changes to a character, and you're doing it in this amount of nodes. And most of these give position updates, and perhaps these position updates actually are in some data file somewhere, and you don't even have to localize these nodes to make these changes to say whatever. And the other thing that I've changed is the variant is called quad instead of biped, or whatever it was called in the other one, base, I think. And then yeah, there's some minor changes to how the post build works.
So just to point it out really directly, we've used the solo of the layer. So we've got these 4 layers that are used to build this. The green one right below the orange is the biped we saw a minute ago. And then the orange layer is just this sort of all the specialty of the quadruped. And we've built sort of a mute and soloing system similar to how you would see in other layered paradigms. So you can so when you're soloing a layer, we're looking at just the information that is specified on that layer.
Yeah, so and we're able to like solo multiple ones. So if you wanted to see, oh, I say that and then it doesn't work. Oh, yeah, it does. It just they don't directly instance it. You can see multiple things. We really don't encourage the paradigm of saving mute and solo into your save files. We do allow that saving. We don't stop you. It's just it doesn't feel right that you would ship your graph with it muted or soloed, but it is a very valuable tool to like quickly flip through things and see like what's going wrong. And then I guess the only other thing is that we're doing this kind of sparse saving of stuff so that this mid node is kind of implied. It doesn't actually exist in the save file. So I can pull open the save file for this exact thing. Let me just twirl up all the nodes here.
So I want to say it's a good time to ask any questions. Where we kind of covered what we sort of felt like was our big sort of all the things demos, right? Sort of trying to get through each different part of the system and kind of demo to you how it's useful and how we use it. And we've got another demo we're going to show you that's kind of like our recent big push we've been making, sort of talking about that, leveling up out of just rig builds and into pipeline builds. And that's sort of our new demo we've got, sort of a experimental, we hope it works demo is definitely working toward that big sort of pipeline goal. So
I think, I mean, it's pretty clear right now. And of course, because I have been playing a little bit before, and now you explaining this one more time for me again. And it's like, it's clicking more than before, of course. And you know, I have this little thing I did with mGear, I will show later. And you go over all the stuff that I had issues while I was trying to figure out stuff there. And it's cool because now, I mean, when we go back to this little demo, we can go again and see where I did all my mistakes before and how this can, I mean, like all the explanation you did, it's a really nice kickstart for the people who wants to start, because it's you pointed all the important like bullet points that I was failing miserable last weekend.
Well, we're glad the demos work. I think Lucas wants to show something off in the save files. I did want to say we're going to try to make sure all these simple builds are available on the website to make sure that if people want to download these builds, just to play with them, mess them up, make layers on top of them. We're definitely trying to get as much sort of content that spans, hey, what is NXT and how do I use it, all the way up to the openRig, which is like this big complicated build thing.
Yeah, it will be nice if we can point out the people also to the openRig. I didn't have the chance to check it out, but I recently discovered, to be honest. It was like, whoa, what's that? Like the other day. But yeah, it looks very powerful.
It's quite a cool system. I know they've just made it public. It's been a thing that we've been working with them. You know, the whole thing is built on the back of NXT, and kind of the first prototype rig of that was kind of our first integration unit test for NXT. It was like, can we actually build the rig? And for a while before we had unit test, it was open up Maya, build the rig. I think we didn't break it with this update. And so openRig has been very intricate to like how we've developed this whole system.
It's like a brothers.
That's right.
Yeah. So this is a save file. Like I said a while back, these are .nxt files, but they're actually JSON. The reason we don't save .json is because we don't want you to believe that we're an arbitrary JSON parser. We're not. Like, we want very specific stuff in our save files. But they're human readable and they diff really nicely on GitHub. We had a long back and forth problem where we had bad merges and we had to change how our save files are formatted. But now it's been a while since we've had a merge conflict.
Fingers crossed. So far, so good. We've been safe on the Git merges.
Yeah, but I mean, this is a big advantage if you can diff and I mean your rig builds and use like Git as a like version control and edit control. I mean, it's amazing. I mean,
Yeah, we've been version control. I mean, the openRig obviously is on GitHub, but it has always been controlled by Git, and we've been working to make sure that it was very clean in its diffs. Like we make sure that when you save like you make a change, it's only that one line of code that's diffed. It's not like half of your file is diffed.
yeah,
We
see
didn't
what I mean.
rearrange all the nodes or whatever. We kept them all in the same order, and we just changed that one.
I see what you mean. Yeah, because if you change the range and then parse the file differently, and even it's the same, maybe just you shuffle the UI, maybe like the arrangement of the nodes in the graph. It doesn't change anything, but maybe when you parse that and save it, maybe it's all shuffle, and then you make a diff, and it's all completely new. But you know, deep that it's not new. It's just UI.
Yeah, so we've done our best to put the save file in an order that cooperates with Git. If you change the positions of some nodes, you're going to see that the positions of those nodes were changed. It's really nice to be able to see actually what was changed.
Yeah, that's great.
Yeah, but so we're saving. We have like a bunch of data that's, some of it is what we consider metadata, and that doesn't matter. If you deleted the entire metadata dictionary, your build would still happen. Comp overrides, 50/50, you could delete that out of your save file and still build your rig, depends on what's going on. We have the reference system, which is just a list of file paths top
so these
to
are
bottom.
your layers. These are what layers your layer needs to work.
Right. So I guess that's, I guess I should flip this view really quickly here to hit. So I've been displaying it as just a list, but the actual reality is like this. So in the, yes, I know. In this save file, the quad, we're just referencing the biped, or the base, sorry, into there. So you can see the base is the only thing that we're bringing into our layer manager. And then we recursively go into that save file and then ask the questions of the base one. Okay, well, who do you bring in? And that's how we get the other ones in. So even more layering, everything's composited. We try to save as little as possible into the disk. So this is all these orange nodes are represented in this save file as just these few nodes here. And then you can see that we go straight from left leg to left leg controls, and that's why that mid one is grayed out. There's no data, we don't save it. It saves on the length of the file, it saves on clutter in your viewport. So we've done a lot to try to optimize the save file. And we have lots of ideas of things to like push NXT more. This is just where it is today, and it's locked at this version right now. And we respect our version numbers because we worked in a pipeline where there was many different departments using NXT, and we had to be sure that if this version number changed, it wasn't going to break it, and that people could depend on that version number, meaning what it meant. So our graphs are tracked in a different version number than everything else, because the save data we want to be separate from any sort of API changes or UI changes. If we rearrange a button, we don't want your graph to become out of date. It has nothing to do with your graph.
And if the people, I mean, it's curious, and probably they will note on your title bar that you have your editor version, your graph version, and your API version, plus the Python that you are loading on the environment right now. And that's something that obviously got my attention first time I opened it. Like, oh, that's nice. That's something probably for mGear we can do something like that, because we have different repositories for different stuff, but we not do it. So that's I'm taking notes, guys. Thank you.
Well, we definitely started with one version number, and then that's how we got into these problems where people's graphs would be out of date. Like the riggers be like, do I need to update something? It says that the version's like, no, we added a button to the UI. So that's why we ultimately separated into different repositories, but why we've split our version numbers into these 3 silos.
And we use that a lot for debugging, because it's like when someone asks a question, we can just like, if you can just give us a screenshot of the whole thing, we'll get the information we need a lot of the time.
Yes, it's easier to send it. Yeah, that's wise.
And you mentioned Python. It's worth saying we've been having fun getting to Python 3. We managed to make the transition pretty quickly, and so far working well.
Awesome. Yeah, we need to go through that on mGear.
It's a challenge.
Starting.
And we're trying to continue to support both, because we do have like riggers working in, back to 2019, I think is the oldest we're lately using. But people need to still work, so we're trying to do our best to keep everything working in both places. We're trying to run the unit tests in both as often as possible and make sure we're set.
Yeah, we still also, like in production, we still in many projects using 2018 Maya, and I guess if this comes for the next Maya version, that will be 2021, and probably will take a few years until all the transitioning, all the people pipeline. So means you have a bunch of years that you must support, I think, Python 2.7 for pipelines to keep running. If not,
and we try to be realistic about it. We do our best to write code that is kind of both, because Python has made that pretty easy in terms of transition. We're doing our best to keep everything as equal as possible, but there will always be things where like, oh, missed that one, just one more piece to pick up on that train. I think it's a never-ending fight.
Yeah, we still get bug reports, because we have a couple of users who are exclusively using Python 3 because they're outside of Maya. So I guess I should have said that this is actually hosted inside of Maya. It's launched from in Maya. We have a plugin that basically just puts all of our code in one spot and launches it. But this window is attached to Maya. We didn't start it separately and like use a command port. We have code for that. That's coming. It doesn't work today though. I'm not going to try and show. I'm not going to show it because it'll just break. So in Python 3, we are supporting it. I would say beyond experimental at this point, because it's what I mostly am developing in, and we have users who are using it actively every day and reporting the bugs. So I think at this point we've like polished out all the Unicode to bytes and string problem, and we're pretty much solid on Python 3 right now.
Cool.
What was the demo we were gonna do? Were we gonna do the nuke one?
If you wanted to show the multi-context demo, we could do that. If you wanted to not do it, I wouldn't judge you, but we've already teased people. I think we kind of have to do it.
We gotta do it, right? Okay, so this is another NXT. This one's running in 3.7. This is running in standalone. What we're going to try to demo is that we have the capability of executing graphs in multiple contexts, is what we call them, which are really just different Python interpreters. So we have, it's crazy, but I'll skim over it. We have an RPC server running in the background that manages calls for requests from NXT the app to run a graph in a context, and then it will spit back the return from that, and it will also give you live logging into that other context back into your app. So I can see the log output. Theoretically, it may work. Quick overview of this graph. Doesn't do anything crazy. It writes a little message into a text file. It goes into Maya and it lays out some joints that spell out NXT. It counts the number of joints, then it goes into Nuke and it tells Nuke what the message was in the text file, like what we wrote in there, and how many joints we made in Maya. It's not any flashy demo. It is impressive that it's running in 2 DCCs and Python, but it's really just the proof of concept that we're capable of doing this. So there's a little bit of spin up time to get that whole server connected in the background, but once it connects, now we're in Python. We wrote the thing, we do a little count out here to prove that we're getting logging back. Now it's going to boot up a headless Maya in the background. Now we're in Maya. It's going to lay out some joints, made some joints. Well, it's making the joints. Shuts down Maya, opens up Nuke. Nuke takes forever to get its license. There it goes. And then it will just write the text into Nuke, and I can open up the folder that all that's going to get spit out in, maybe.
So, I have a question here, and this is like right now it's you running these applications, but in the future it can be possible to run in parallel, like to launch 2 headless sessions of Maya, run different things, throw it, save it somewhere else. There is when these two finish, there is a third something that takes both results, match it together, so you can parallelize builds. And well, I'm always biased to think about rigging, but that that it's gonna be super hot, I think, because
so parallelization is another big layer on top of this whole thing, right? It's like it's because we work in layering so much, I think about everything we're building in layers, right? And so it's like this, I feel like we've just sort of reached this base layer of like, haha, we can do many applications in sequence. And then now we've got to take this other big step of like, now we can do many applications at a time, you know, in this big parallel sort of format and in sequence. And I think what you're talking about, that parallelization, is obviously useful on a local machine, but really steps up in usability when you can say, send it off to a farm and get back the information later on.
Yes. For instance, in our projects, we send rigs to the farm to build, but of course it's one build, or you have, in some situations, you have one build that builds the facial and store it somewhere, and then you have another build that expects to have one Maya file and build it. But if you want to refresh that, both of them, well, basically you put in the farm first this and first this, so it's not, I mean, you cannot parallelize like a lot clearly. I mean, you can do it, but you need to keep track of like what you build first and so on. So if you can do this, and when we're talking about like scaling, like in terms of like in a production, you can have like I will not say 100 characters, but maybe between variants and different resolutions of the character and so on, you can easily hit hundreds of different rig assets. And then when you need to edit something because X or Z, I don't know, but like bug that you need to fix in all the rigs, or big change that comes from our department or something like that, so you want to trigger that in in as faster and efficient as possible. So if you don't need to change the facial, well, you want to build the facial, but if you want to build all together is when you have this kind of how you do it. No? And right now it's all one big monolithic build, so you need to redo everything. It's not that bad. I mean, we're talking about a matter of minutes. It's not like a rendering that it takes forever,
right?
But still, like, can be better.
So I mean, the rig changes type of thing is exactly the direction we're heading. And looking at these sort of multi-context graphs, the next layer of all of this is thinking about the idea of, hey, I just finished working on this fix for the build. Let me not only send this rig off to get built, let me run some calisthenics on it, get a video back of calisthenics sent over to my Slack channel or whatever, and then let me kick off 5 shots to go be, send you back the play blast of these 5 shots with that new rig to make sure I didn't screw something up as well. Like, just to give you that broad QC, I think that these multi-application graphs are those type of tasks are the thing we're hunting for. Sort of that big, hey, do this, and then send it all back to me later. I'll watch for the results, kind of thing.
Yes, that's absolutely must wanted thing. I mean, on our case, like, I'm always talking about my case. I don't know how everybody's doing the things, but yeah, we do have that, but it's more like in the pipeline way to do the things. So we build and we can run the QA checks. We run like a Pyblish. I guess Pyblish. It's the and we on all these validators, and then if pass the validators, we send it a couple of like calisthenics clips that we have ready, facials and body, send it to the farm, and we get everything like the rig publish. But it's not like in a graph like this. It's the pipeline tool that it's cooked like that, let's say. So if you want to change that, you can run something else. You need to go on the code and change the way that we do this validation. So it's not like, of course you can check what you want, but let's say, like you said, like, I want to run after this and this shot later, after pass all these things. There is where that should be something more involved to do that, and you cannot change it by like every time you do it. So it's not like flexible in the terms like, okay, this time I want this and next time I want the other thing.
Right.
Yes, and artists being free to crack open the tools and make those tweaks and that kind of stuff is the
Yes.
total direction we're building toward, right? It's like
Yeah.
NXT graphs are built for that.
Yeah, absolutely. This is what I meant. Like the artist wants to change the. So this is what the pipeline development department give you, and you can do that. But if you want to change that, you need to go through pipeline in many situations, many edge cases where I want to check this, or I want to do this extra like step or formatting, for instance, like extract the data to create FVX data because you're gonna go to motion builder later, things like that. And then when all these edge cases or unique scenarios happen, it's where it gets expensive, very expensive. So you have the standard, it's there, monolithic or not, but you mean like it's the base, bread and butter. But then when you go, oh, and this character I need to do these checks because he has I don't know, like an Alembic streaming thing with changing topology that needs to be checked because then goes to Houdini effects, whatever, blah blah blah. And then you have a super specific edge case that you need to test with a different way because you need to pop this Alembic to test the streaming, blah blah blah. So, well, we're stuck. We need to do by hand.
Right.
Yeah, we hope that those things become layers on top of the pipeline tools. Totally.
Yeah. One thing we didn't quite talk about, it was happening, but we didn't talk about it, is that our Python API lets you replace any attribute value in your graph before it runs. So we have some like basic graphs we've used for pipeline publishing that don't, they're kind of dumb graphs. They're just like, we know the steps, but we need all this, we need the signature put into it, and we can put that in from Python with just a dictionary of node path to the attribute path basically, and then the value. So that allows you to do those kind of, you can have one graph for your farm publish, but you can fill that dictionary with different data through the Python API. So you don't have to have a graph for every single character. You could have just like one central, this publishes a character, and you know, you fill in the name and whatever, the directory, and the rest of it will just kind of happen because of the inheritance of those attributes.
And I'm sorry, I was listening and I was looking at the screen right now, and you pop here something, the workflow tools.
Yeah.
That I didn't see it on my version of NXT. It's there. I didn't, or this is something else. This is something that comes from openRig and it's pipe here, haha. Because it looks like rig stuff here.
It's part of NXT. It is, as of recording this, not documented on our website because this is something Aaron Adams wrote and did for us because we needed it and we didn't have time, and he was like, I'm gonna just do it, and he busted it out in a weekend, and I don't really know how it works. But what it's capable of doing is turning your node hierarchies into this Qt doc widget where you can create buttons, and these buttons are capable of executing nodes directly. So it gives you like a,
because they are
like a
nodes?
picker. They are nodes, but they're able to run other nodes. Like there's tooling in here to be like importers will go and import the skeleton, and it'll just run that part of the build. And this is how the riggers are actually interfacing with the rig build. So they'll start the import, they'll bring in all the stuff, they'll paint their weights, they'll go to the exporter, they'll save out their weights, and then they'll kick it to the farm to do the full build of it. So this is like it's a whole other thing that like we don't have time to go into.
Part 2 of this podcast because of course I mean it's just my how you say, my carrot for
yeah.
What's this? It's it's very interesting. So you have this, and I guess there is an equivalent on your graph or somewhere. No, it's not there.
So that's what this hierarchy, the rig workflow, it doesn't have to be called that.
Oh, okay. I see the importers, and you have the importers there. So it is something.
So you have like it's a one-to-one analog basically of, and then these are, depending on their instance that they're attached to, this doc widget code knows how to draw a button because this node is instanced from a button, so it makes a button.
So to talk a little bit about sort of this is, I think, useful to talk about design philosophy. So we talked about all these things we built for NXT, and we're doing our best to make NXT itself be as little as it has to be, and then build pieces that we want inside of NXT. So a lot of the rig helpers you're seeing here, these are kind of built inside of nodes themselves. Like the nodes contain some of the code for this. And that multi-context graph that Lucas showed before, many of those nodes contain the code to do things, if that makes sense, where it's like the code to run a whole other graph as a node is only a node. It is a layer you bring in, and then you can do that work. So we're doing our best to keep NXT, the system, as simple as possible and sort of as dumb as possible, for lack of a better term. We want to be just Python as much as we can, and then build those extra layers on top of it as NXT graphs that you can bring in and use if you want, or you can sort of ignore and not have to worry about. Take the problem in bite-sized pieces.
So, and this is these nodes, but the other nodes, they didn't have code inside, or it was like I'm just not.
So this is sort of a 50-50 approach in the other one. The sort of subgraph stuff is a bit more directly code node blocks, but this workflow tools are a little bit 50-50, where the node graph defines some of it, but we do have some internal NXT tooling that does some of this work as well.
So you have, okay, I'm just losing track here. So basically, some of the nodes. Wait, because I thought it just getting, so for instance, the one that import the model, that it's the button, this is, you have the model there, then you have the import, and you have the button, and this inherits from a button.
That's right.
Yes. So the button doesn't do anything really in the NXT
that's
world.
it thing. So it's an empty node.
Yes. It's just
magic.
Some information here, and then we have an entire library written in the actual editor that does the Qt drawing. We're not doing Qt drawing in nodes. Maybe one day. We have ideas. We have lots of cool ideas, but we're actively trying to produce characters. Our main goal is like get characters out, but we have ideas for the ability to interact with the interface directly from a node. Which is not what's happening here. That Qt code that makes the buttons is in another library that knows how to read these. It knows like, oh, if I see button color, then that means I need to paint that button.
Because I'm very well. I didn't talk about like the what I wanted for mGear in the future. I think maybe I will. I need to do a little explanation why we are talking today, because that's interesting.
That's true.
Also,
That's true.
And the other thing is like this part is very interesting for me. So let's if it's a good moment, I will do a little explanation. It's basically I did was this September on the SEDEC here in Tokyo. I did a little talk, and at the end of the talk I explained a little bit what was my roadmap for the future, and I was hoping to do something similar to NXT. And when I say similar, it's like I'm upgrading myself to something high level, because it was like 1% or even less than what you have. So my biggest hope was, my crazy dream was like just a grain of salt of what you did here. So that was the original like pitch that I did there, and then I did recorded the video, this presentation again to put it on YouTube. And I don't know who of you guys watch it, and you contacted me. Hey, maybe we have something that it looks like similar to what you pitched there. And obviously I didn't have anything yet. It was my goal for next year, 2021. Yeah, I don't know the time we publish this podcast if we will be already in that year, but so what's my like roadmap wish for that for 2021 now. And when you told me you had, and you showed me the stuff the first time we talked, and say, okay, it's done, I did it. Yeah, open source. So I'm not gonna do anything, because you have like done like million times what I could imagine. So it's like, no, for me it's no sense. And obviously my next thing will be, okay, I need to test this and see if it works with mGear and so on, and it worked like out of the box, like perfectly. Perfectly it worked. I had some questions that it was more on my side than the system itself, but it did what I was expecting for sure, and much more. So the other thing, it was on my pitch, and that was something I was willing, very interested to talk with you guys. It's the what you have here, because you have the code, and we can encapsulate. This is the part I was playing mainly, and you have the attributes, and I was thinking, okay, so I have the attributes and I have the code, so I can create these nodes. But you also showing me now that there is a possibility or a way that you can even have nodes that directly don't have the code, that it's kind of like already pre-built sort of node, so the person can just set the attributes, and if you set the attributes, you don't need to change code. So it can help, like, to even for if you don't have the person who does the code for you, you can use these attributes, or sorry, these nodes that just need to input the attribute thing, and it will do tasks for you. That's how this buttons thing works, or it's something that it's not exactly what I'm describing.
I think it is. I would hesitate to say that we do that right now. I believe it's in our minds that we want to have this ability to have pre-built libraries that are plugins, and a lot of what we've done is very plugin oriented, as far as like the ability to execute in Maya and Nuke. That doesn't ship with NXT. That's something that is a plugin that's very easy to write. It's like 3 lines of code to write it, but it is a plugin, and we hope that workflow tools will become our GUI plugin. Right now there's really no easy way to get in there and mess with it and change how it works, but we want to defactor it and make it into something that can expose, like, this is the depth that you could take a node to. You could take a node to this level that it is actually a button, and it has all this code, but that code is in a library somewhere that doesn't have to be exposed to the artist. It just does the thing that you want it to do.
Because that will, that's awesome, because I for me, like, if I want, I can right now, it's you can use mGear with this, no problem, the way that you use mGear before. But next step will be like to maybe provide a library that, or plugin that can give NXT the ability to just allow the user to don't have to code inside the node. Just get the node, and I want to import mGear skinning, import, and you have one path where you put the skinning path, and the node will understand that needs to use this library from mGear to import this and things like that, instead of
we're really excited about layers and these projects people can share with each other. In fact, we have someone build a colleague of ours from Sunrise is actually building a USD toolkit. So she's gone through all of the USD examples, and she's translated all of those into NXT graphs, and it's really, really fun to kind of go through these graphs, because I don't know how deep you've dived into USD. It's a pretty confusing concept. There's a lot of different pieces to it. And the NXT graphs has been a great chance for me, someone who, like, we worked with USD. We have a basic working knowledge of how it works, and we've done some stuff with it. But these NXT graphs are a great way to get another look at them in a new format and go, oh, okay, there's some things I can see here that I couldn't see another way. And that's a great example, I think, talking about the mGear graphs that could come along, is the same type of thing where it's like, hey, what are the sort of ways people want to use USD? She's built those graphs. And so thinking about from your perspective, it's like, how do people want to use NXT with mGear? You can start to tell people that by delivering them graphs and going, here, try these layers in your graphs and see how they work.
Yeah, because if the people, right now the node, it's only node, and you put the inputs, or the attributes, and it grabbing the information for you. You will have in the future nodes that are like more like I will say like hard coded or something. Yeah, I don't know, like import skinning node or process USD or import the, I don't know, like for scene assembly, things like that. That it's more like I don't know if it's called like high level or that
Yeah,
it's just
Yeah.
a little interface or something that
Mhm.
instead of the code area snippet.
Yeah, and I mean, a big priority for us is exposing as much code as possible to artists. So even if you are tweaking things you don't understand, you can kind of get a hint of what to understand. And so I do think it will remain important to us to have ways for people to look at the code that's being run.
Yeah.
And I think that the context stuff that Lucas is showing off and the subgraph stuff that's sort of the other layer of that same stuff is exactly the stuff you're talking about, where someone can grab a node, hey, it works how they want it to work. They can override those things. They don't like the whole code editor can be closed for them. They don't need to worry about that code. They can just worry about those attributes and it's going to do what they ask it to do.
Yeah, yeah, definitely. And for instance, if I have this pre-made like node, let's say with the way that we have now, that I have this node that runs my custom step in mGear that does X or Z, whatever. Can I export only the nodes so that people can get these nodes in a library or drag and drop or something where it's this pre-made like nodes with even with the code? You know what I mean? Like
Yeah.
that's
yeah,
something
like
it's doable, or
because of the nature of because it is just JSON and we're doing this like as simple as possible and not trying to reinvent things. Nodes can be copied and pasted as plain text right now. And so ways that we've done debugging in the studio is like some node, something is giving them a problem, highlight the hierarchy, copy it, paste it into a Slack message. I can copy that text out, paste it into the viewport and get it there directly. So you are capable of extracting pieces of it. We don't have right now, we don't have a way of saying like save node as layer, but definitely like that's on our list of like early things to do next year of let's get it so that we can, you can quickly prototype something and be like, I just want to extract that one node and then right click, save that node out to somebody else.
Like maybe like just take the node, select the node and export node and it just get this node. And maybe if you add like a drag and drop or something that you can with the NXT extension. And I mean, well, I'm talking without knowing, but it doesn't look like super. I mean, you have a lot done that it must be something like can be.
Yeah, we have a lot of the building blocks for that. We just need to sort of arrange them in the right order.
That will be awesome because that can give a lot. I mean, open a lot of just give this library with nodes, and you just need to load whatever you need for build again, and that would be awesome. Can we? I mean. Do you want to jump on my little thing and you correct me all the things I
Sure, we don't have to spend a long time on it. I think we've been going maybe about an hour now. We can spend some more time if you're interested.
Yeah, it's up to you. I mean, guys, I don't know, it's something else you want to show, like
go ahead, Lucas. I've been through everything I want to show.
I didn't plan on showing workflow tools, but I just it felt like the right thing to show, and I don't have anything else that's ready and fancy to show. So if you want to show the face rig, let's
look at that.
So okay, let me say share screen, not this one. Share screen. Yes. Okay, so well, basically I did this weekend this build that this is the character I'm doing for the workshop that I'm on YouTube. So is this just simple facial rig example, and this is exactly what I have until now done on the workshop. So with a bunch of custom steps and everything, all the data is serialized and rebuilt again. And I took all my post custom steps and I built it here. So I tried in two different ways, and you point me some stuff like this one with inheritance and this one with the connections. And well, you commented a few things. So the first error I had that you told me was the way I was accessing the build dictionary, and then is when you explain it all the stage object. How you call it? It's an object, a stage. How do you will?
So the words we use are stage object, and it's definitely something we're working on. Like we don't have a perfect name. I think this is like many things with NXT. We're discovering, hey, we have the way we understand it, and then other people come to understand it in a new way, and usually that refines how we talk about it. So yeah, the stage object is the best name we have for it right now, and it's just kind of the through line that travels through every single node.
So that was my first let's say mistake I did, because I was trying to pass as an attribute the dictionary, and that's something that you explained before on today's podcast. Like the right way to keep the objects, the Python objects, is not using attributes, it's using the stage object. That was probably the most revealing information I get it trying this. And then the other thing was the way that I imported my my libraries and my things here, is that you need to use this the global import, or the global variable, so you will have everything in global. So, and that was interesting because I imported here, and the thing is, sometimes for instance, I have access to this object here, and I have this silly print there, sorry. But the way is, I was accessing my custom step like a facial base and try to access this object, and it was giving errors like, oh, you didn't import PM, and I was, wait a second, like PM, sorry, Pymel core. So I was thinking, well, but I'm not calling Pymel here, I was calling it here, and this already passed. Why is, and it's because it was accessing the object there. And so it took me like a little, and I was watching the videos and so on, the tutorials you have on the documentation, and I found out that it was using this global. So I started to play around, and it, depending of how I use it, I didn't need to import all the like in global all the imports, but yeah, some of them. And then you told me that I have this main thing I didn't know. No, that's, so I should import everything here. So for instance, these ones, I should not do this here. So technically, if I delete this, well, let me edit. And now I'm gonna screw everything. No.
And just live coding is even more dangerous than a live demo, so good luck.
Yes, and technically it should work like this.
Yeah,
that's
don't
right.
forget
You
OS.
should not need the global keyword.
You don't need the global keyword, no? But
no, not at all.
What is? I did.
You deleted the OS import too with the global names, I think. But
thank you.
Otherwise, I think it will be.
So something like this. Oh wait! I'm just.
Wait, I move all the.
What I'm doing? My God.
2 clicks on the layer name.
Yeah, click here. Yeah, that one. Yeah. So that should be all. And now every of these like snippets of Python code, it will know. Even this one, I probably can import it here. I mean, remove it from here, because I'm importing this in each single custom step, because it's the way that the custom steps are done now on mGear. So I don't have here open my my guide, but basically it's, I mean, this is all the post and it's all repeated. So if you want to use,
I think one thing I should clarify for people that might be confused by what's going on with this global keyword, the module, when you import it, it registers that module object into the modules dictionary in the Python interpreter. We're not unloading the modules. We're not pulling off, like Charcoal editor in Maya has this like thing that it will try to like clear out your modules so that you can like not have to do import reload. We're not doing that. All it's doing is it just doesn't have a pointer to that module. So don't think that, oh, if I import this specific module in this node, on the next node, the module will be out of memory. That's not what we're doing. It's just the global keyword name is not stored.
It's whether it's just whether the node has access to the module. That's what you're changing, and you got it right. On the world node, any imports, those will be available to every single node.
I see. And just to try here on the facial base, where I set my strings for the objects, I just did one. I was a bit lazy. Sorry guys for that. Shame on me.
That's okay.
Wait, I'm just checking. Wait a second.
You might have to hit escape.
Yeah, exactly.
And,
and here, here is it.
There you go.
So you can do. I mean, the way that I was doing it here, you can add the rest. So all these settings that I have at the beginning to set all my objects can be set here. So next time someone wants to use this template, instead of going here and instead of head, it's, I don't know, face geo or something. So you just need to go here and change this string here, and everything will work. Or if you do like an instance of this, same thing. You just need to override that part, and this is giving access in a much more elegant way than just going here and changing the code here. So this code can fit now many different names or different geometries for the same like part that it's the head itself. And I don't have to, I mean, the node, the custom steps that I have here right now, I can have some advantage but on this, but not that many right now, because the way I'm doing is my fault or my lack of like flexibility here on these parts. But in the future ones that I'm gonna do when I finish this workshop, there will be parts like when I do the tweakers and things like that, that I can take much more advantage of this, because I can set the tweakers for per edge. So I want this list with edges, so I can expose this, so next time I can reuse this node with different edge system, and I can change this list and it will generate different tweakers on the face. And there is when I will reach that point on the workshop or on this facial riggings where we can definitely can take full advantage of NXT for have this flexibility for future rigs. And I'm saying this, and maybe I should add some chapters on the workshop to use to transfer everything to NXT. Yeah, I will do that. Yeah. I'm saying it here, so I must do it in the future. It's recorded.
Well, hopefully we update our documentation so that you don't follow the video that says use the global keyword, because that's a really old video that we haven't had time to update. But hopefully when this comes out, we have new tutorials.
Well, I mean, it worked. So anyway,
it does work.
I'm glad that you got some value out of those videos. We're really proud of those videos. I mean, those were our first big chance to like, okay, let's teach people how to use NXT, and we're excited to do better on those. I'm glad that they got you through some of it.
For the people who is wondering, it's talking about these videos here. I don't remember which one. I was like just rechecking every video. I don't remember which one was the one I found. Probably one of the first ones, I think. But yeah, it's here, and we will add all these links on the podcast video description on YouTube, so everybody will have access directly to the links and everything. So do you feel I should try to build this again?
If you'd like to do it, we can have a go at it.
Okay,
I'm sure we can figure it out.
Don't laugh on me. Okay, I'm gonna try this first. That it's the one I messed around. I have the other one that I know it works. So, and maybe I should do like you did, like this. Oh, look at that! My Maya crashed. Shame on me.
I hope that wasn't our fault.
Wow. That's
Maya. Maya will do anything for you.
Oh no, indeed, I'm just running the wrong Maya now. That's very unpolite, Maya.
We do our best to try to keep NXT from tearing Maya down with it. We have an accept hook in there that tries to stop Maya from fatal erroring if we fatal error, but you know.
And we've talked about sort of our ideas for remote. Like that's one of the this crashing is actually one of the big reasons we'd like to get separated from Maya, is so that in the future, if NXT actually attaches to your Maya session instead of being a part of it, then when Maya crashes, NXT doesn't, and when NXT crashes, Maya doesn't. Just it's better for both, really.
I don't think it was NXT who crashed. No, it was. Was adjusting the. I don't know. Well,
I hope not.
Let's.
It's live demos. Like what? This is what do you expect?
It's gonna be fun. Okay, let me load the plugin. as you can see, I have it prepared just in case crash everything, so I don't have anything prepared actually. Okay. So it's loading.
That's really slow.
I'm sorry. I maybe it's my on my end.
The top one, open editor, yeah.
Okay, so I have it there. Okay. Oh, but I lost my. Ouch. I lost the edits I did because I didn't save. So maybe it was a little trick on my side, so I don't shame myself in public by running something that doesn't work. Okay, so I'm just gonna run this. I was trying to, because when I run this, the Maya session takes the focus, so I'm just gonna try it again. Do you think I'm gonna crash if I do this?
We'll find out.
No, that should be fine. I don't know.
No, it
All right.
didn't crash.
This time it worked.
Okay, so just gonna make this a little bigger like this and try out. So just building, and it's showing everything here. This is, by the way, this is a gear shifter lock window. It's just on top of NXT, but that's unfortunate because I wanted to see here the process on the other ones.
You could see the lines behind it. It was going.
Yeah, I just kind of. Oh yeah, I move it.
Yeah, we do. You kind of have interactability while it's executing. It doesn't. That's something we didn't even talk about. The part that you can pause your execution.
Yeah, you have like kind
going.
of like breakpoints. That's true.
Yeah.
We do have breakpoints, and we're working toward what we hope to be sort of as close to a fully featured debugger as we can. So you can sort of, as in the middle of a build, you can pause it, change some things about your nodes, and then let your nodes keep running. We're excited to get there, but we're not there yet.
Yeah, that's a big thing. I don't have that on mGear. When you run, because the step dictionary gets garbage collected each time. Well, if you don't catch it, of course. But the way that is done now, it's it's gone. So sometimes it's lost. So well, I have the rig again built here, and it was done through NXT. So okay, I passed the FACS exam. That was the punctuation.
Well done.
A+. Yeah.
A+. Thank you.
There you go.
So, and it was very easy. So a part of the import thing, the only thing I had to do on my side, just the different that the people, if the people is following the workshop and they have access to the sample data that it's bundled, it's to add these lines here. So basically, the first line is just creating the instance of the class custom step, running the main method. So it runs with the stage step dictionary. This is the one that we stored at the beginning, so we need to keep track of that by yourself. And then last part is just take the step that we just created and add it to the staged step dictionary with the name that is the name in this case. The name is mouth plane shape. So with that, with these 3 lines that you can copy paste in each node now, custom step at the end, you will have the same behavior. I do this under the hood on the build on mGear, but obviously here you need to take care of your dictionary and grab it, everything, and set the key. But this is basically what like shifter build does under the hood. It's not, I mean, indeed I just copy paste it and just change it to step dictionary and put stage in front. So that's it. And it works. So it's amazing. Oh man, that's a lot of fun in the time to come.
Well, it's really exciting to see just how you've done in this little bit of time, what you figured out. And I would love to keep going with you. And you said you might want to do some stuff on the workshop. It'd be really fun to continue to collaborate and try to see what else we can do. Looking at that final 3 steps, like maybe there's a way we can make it so that NXT can actually sort of define custom steps for mGear that can just sort of be handed off like a graph.
Exactly. So that's one of my goals. Like we need to keep talking. Obviously, this, I think here on the podcast is not the place. Not that we don't have the time, but yes, definitely something I want to go forward and have this more simplified. We don't have this imports, and obviously the way I'm handling the things to see how can be handled better here on NXT, and how we can make it easier. Maybe this is the way I was doing it before, but it should not maybe be done like this in the future. I don't have all the answers. I just know what I was doing. I was trying to replicate it here, and it worked. I mean, like that's very important. So we can start from where we left, or from where you left. I'm sorry, my English is horrible sometimes, but like, you know, it's just very easy transition. What I'm like, we have these custom steps that is in the guide. Now we can have the same here without too much hassle or too much problem. Just take what you have and move it. And by the way, I was trying to update mGear to have some like stuff here, like this here that runs and carries the dictionary, but it's not needed. I will share this snippet also with the video. So basically, you can run this with the actual mGear release, so you don't need to update mGear if you're using already in production version, then you're locked with that. So you just grab your rig object and just your configuration, that is the serialized guide template, and you can build it from there. And when you build it, the only thing that you need to do after, so this is the build here, it's just to stage this custom step dictionary here, boom, and it's done. And these two lines at the end is just to handle the shapes of the control, so it's nothing related with this step dictionary or anything. It's this line here, the only one that you need to take care, and everything will work after that.
Very cool. It's good to hear that it just kind of dropped in and worked, and it didn't really give you any crazy problems.
No, I think the only problems I had is with myself. Don't read in documentation. It's yeah, read the docs.
Well, we want to make the docs as easy to read and as good as we can, so that you only have to read just the parts that you need. And man, it's been a real pleasure. I really appreciate you letting us come on and talk about it. And like, it's so fun to hear just even the things you run into, the things that were hard for you are super awesome for us to take back and sort of roll on and let us think about how we can make NXT better. Because I think that's the thing I'm most excited about. Like, NXT has been, it's not whatever closed source, but only the people who have been reading the source of the 10 or 12 people who've been using it with us. And so I'm really excited as we go into the open source, and it's just freely available for everybody to check out. I feel like there's so much chance for collaboration, and we're going to learn so much about what NXT is good for, what it could be better for, and all those kinds of things. And I'm super excited to do that.
Yeah, and well, just let me make this bigger so everybody can see our faces better. So yeah, for me, this, I mean, I don't have words of gratitude for you guys to first to contact me, because the was amazing, and the tool that you did, I mean, and you're working on it's you can see the like the amount of care and work that you put on this tool to make it like production ready and sleek as, I mean, I cannot ask for more, honestly. And you saved me, because I was towards to do something similar. I mean, you save one, well, put it in context, the part I wanted to do, the little thing, the niki, it probably would took me like a year or more to do what I was aiming to do. So I'm not thinking to do same as you did, because you've been involved, like you told me, like you've been working on this for years, a team, full dedication, and you can see that it's a labor of love, you say.
Absolutely. It's been a lot of work, but it's been so much fun, and we're excited to see what comes next. We think that going open source is going to be a big change in how we interact with NXT, and we're excited to see how that changes.
Yeah, and about open source, yes, open source, everything it's in GitHub. License, it's MIT.
That's right, MIT.
Yep, that's awesome. So it's same as mGear, so we can be friends forever.
Friends forever, that's right.
Perfect.
And yeah, I'm very excited to to take. I mean, next year is gonna be very exciting for everybody. I think on your side with your project and on mGear project also. We have a lot of goals to achieve, but probably the one of the big goals, it's gonna be like to make this NXT and mGear work together much more I would say like cohesive. I mean, right now it's work. I mean, I don't know how to put it this with a word that I don't diminish what we have now, because right now it's working. It's cohesive and it's it's really nice. So, but just even more like make it stronger, the connection. That's something that I'm looking for to do.
It's exciting. I'm glad that we got the opportunity, and I'm glad that like we were able to connect, and that you were willing to like listen to our little pitch like a couple months ago when we pitched this whole thing, because we didn't want to come in and be like, yeah, your idea is great, but check out ours. Like we were like, no, like this is going to be open source, it's going to be cool, we can work together.
No, but it was the other way around. I think it's I had this little pitch idea dream, and you came and say, look, we did it for you. Well, not for me, but for you, for everybody. But you know what I mean? Like, it's like, oh, check it out, guy. We have this. And I was like, oh, like, I felt like, I don't know how to express, but it was like great. And and this is the things I like the most about open source. It's when you have these kind of connections. And I mean, everybody that we work on this industry, I think we are willing to share and to I mean, the community, it's very strong. And it's cool that some people do feels that there is a need for something, and other people have this feeling like kind of intuition, feeling the force. So I don't know how to say that.
Yeah, feeling the force. That's good.
Yeah. I'm going geek here. But yeah, at the end, it's very I don't know. It's great when you find these connections and these alignments on the train of thoughts, and you can collaborate and help each other and share also the fruits of this, because at the end it's our work to do like final things like animation, games, and things like that.
We're doing all this to make cool stuff.
Yeah, exactly. So yeah, that's great. Okay, so I think we can wrap here. Thank you guys, thank you everybody on this project, and thank you for contacting me like two months ago, and
of course
make it happen. Yeah.
As we're finishing here, I want to make sure that I say a big thanks to Aaron Adams, who isn't here to help hang out with us. A big thanks to Zach Gray as well, who did some of the tutorials that you watched. He's been a huge help to us. And man, there's so many names. I'm going to not say everybody, but really just Sunrise Productions and the School of Visual Art over at Southern as well helped us out. And we've had so many great people that have been around us and helping us out. Matt and Wald over there with SquareBit, and Sergey giving us the cool roller girl to show off today. I mean, really, we've had so many people that have been around us to help us. And so a big thanks to all of them, and you included, of course, for having us come on here, the podcast, and get to talk about it with you. It's been super fun.
Thank you.
Thanks for having us. It's been great.